Hello and welcome back to Maskimila Learning and Maski TV. Grade 11s, today we are here to try and analyze how you can reply to any financial means, come exam and come test, right? So let's dip into it together. We are doing financial means today, which we call it finance, growth, and decade, because it increases and it decreases at all time. This is part of your paper one examination or task. So there, at the end of this lesson, you need to be able to work with a simple and compound interest, which we literally call it a growth, because the interest is actually something that is increasing all the time, right? It can go up, and that is why we are saying it's a simple and compound growth. So we also have to know and understand the use of simple and compound decay, because that is then when it declines, which means that whatever interest or money that you had will have to keep on decreasing at this point. And normally that is for when you deal with like loans. As much as you are paying, it goes down all the time, or some things that are natural when we buy. And I'll show you the example of those kind of things as we go on. You need to understand how to deal with nominal and effective interest as well. Right, so here you can see there's formulas that we have put down, which are the formulas that you need to know. Remember, grade 11, the formula sheet is not given to you. So what it is that you need to know is to understand which formula to use when, and what it is that you need to highlight for you to end up using that formula. All right, so here we have a simple growth, which we call simple interest. That is actually a linear or a straight line formula, where you can see that everything that we have here has just been on a straight line. So each and every letter here represent a particular information. For example, A will represent the total amount of which you have saved if you are saving, the total amount of which you have invested if you're investing. So that is what you can say to your mind as you see the A, then say that is my total amount, while P, it's usually the invested amount or the money that you are saving. So suppose you're saving 500 per month, that will be your P. So you can actually call it just saving, but in context, they call it a principal amount, right? So that is what they'll use. But for now, let's use normal words that you can be able to relate to. Then we have I, that is actually your interest rate. So interest rate says sometimes they can tell you you are putting money and then you're going to get like 12%, and that will be your interest rate, which is I. And then N represent your period. How long are you going to be investing? How long are you going to pay that loan back? Or how long are you going to be saving that money? So that we call it a period, which you can actually call it like how long, as I'm saying. So for both a simple and compound growth interest as well, this will have all those letters that we have just identified. The difference here is just that the compound one, it is an exponential kind of an equation, because it has the exponent of n, which we said n is a period. So that is the difference there. That is in the linear one, or in the simple interest, your n, it's not an exponent, it goes with your I and everything else. But then in the one for compound, you will see that that is now as the exponent, which is an increase of a particular sort. Okay, so like here, if we try to use these two formulas and calculate how we're going to get this done for both simple and compound interest. By that time, I was teaching math literacy. I remember then I would always say which one is better for you to actually use. Or if you go to the bank and they say we're going to compound you monthly, or they're going to say we're going to compound you yearly, or they're going to say it's in simple interest, what does it mean, right? So you need to always check those kind of things. In this case, if we have been given, so if I want to use the simple interest one, let's see. If I use the simple interest, if I use simple interest there, what can happen with the simple interest is just simple that I can copy the formula down so we know what A is. We can be able to find what A is. So let's copy the formula Let's do the substitution. What is it that we have? We say that an investment is the money that we are going to write as P. So that if we put that as 5,000, then we have 1 plus, and then we have 8%, which is our I. You can write it as 8%, or you can write it as 8 divided by 100, because a percent is represented by the division of 100, and then we multiply that by the N, which is what is given there as 3 years, which is going to be 3. And if you calculate that, you should be able to get to the answer, and then you can be able to do your rate. So with my calculator there, I'm going to just quickly calculate it down. So usually in finance, we are advised not to calculate things part by part, but all together at the same time, to avoid errors and misunderstanding, especially when there is commas into the solution, so that we don't go and use the commas there. So because it's money, we write it with R, and it gives us 6,200. That is the amount that we got when we use the simple interest calculations. So let's go for compound and see what we are going to get. If we use compound interest, let's see what we are going to get. So A will be equals to, our formula is P 1 plus I to the exponent N. Always copy the formula down. That will help you to then write everything that you have and know what you don't have. So the P stays the same as 5,000. 1 plus our I still stays the same as 8 divided by 100, or 8%. But then our A as an exponent is going to be 3. So if you do that in a calculator, as I said, try to make sure that you calculate and then you calculate them at the same time in all cases, so that you don't make mistakes, especially when there's decimals. So that gives me as 6,228 rand, 56. So that is what I'm getting. So if you look at that, you'll be able to see that for simple interest, the answer was 6,200. But for compound interest, the answer is 6,298,56, which means that for compound interest, there's an additional of about 98 rand, 56 cent. So that is what you need to know and understand, that now we just have confirmed that with simple interest, you're always going to get lesser than what you would have got if you did it with the compound interest. Okay. So as we are busy with this, just always ask yourself, which of this or anything that is at home do you think grows compoundly, and which one that grows simply, right? So which one, if you look at the interest of saving an account, if you have an account, or you can ask your brothers, your sisters, your mothers, if they are saving, what is an interest of what they are getting? Is it a simple interest or is it a compound interest? I promise you, if it's simple interest, the growth is very, very slowly. But if it's compound interest, the growth will increase normally in the monthly or in yearly, right? So with also check with the food and the petrol. What do you think? Is that simply, or it is compoundly interest, or what is happening in the growth? Also the population of our world, what is happening there? You can always just do that, or check, or you can ask Maski to get those kind of information as well. And then we have another formula, which we did say that is a decay. So the only difference here between the one that we have done between growth and decay is just the sign, right? If you check the same formula we had, the only difference is that this one has a minus while the other one had a plus. That is the only difference, but it does make a difference, because this one just simply means that it's going to decrease. So in most cases, it will be used in the things that loses value. Like your phone. If you buy it like 2,000 today and you want to sell it tomorrow, that is not going to be 2,000 anymore. So that is an example of what we use this compound and simple decay in comparison to the one that we use for growth, right? So the real life situation, it can be the car, for example. A car loses value every single day. Unlike the house gains value every day, right? So the car loses value, and as I said, your electronic device, the furniture that they have at home, and all those kind of things, they lose every time when you have it with you. The moment you get out of the store, and sometimes even if it's still at the store, it does lose value every day, right? Then we have the part of application of what we do with the decay is that we have something we call straight line depreciation. So the straight line depreciation you would have seen, that is the one which is our straight line with a negative, which we said it's actually the A equals P and it has 1 minus IN. So that is the one that we use for the straight line, whereas the one that we use for reduced balance will be the one that is literally in percentages. So it does lose, all of them will lose, but they lose depending on what it is that is scaled on. They can say yearly, or they can say you're going to lose like 2% every year, or they can say you're going to lose 3% monthly or quarterly, and so on and so on. So that is the example, right? Here, if you are given or you have a laptop that is worthy of 12,000 and then it depreciates like 15% per year on a reducing balance, then you can then calculate after 3 years, which is similarly to what we have done in the other side. But for this, you can actually compare the two as well for you to see what it is that you will get. So you can use the formula of the simple decay, A equals P 1 minus IN, and you can also use the compound one, which is A equals to P 1 minus I to the exponent N, and see what comes, right? You need to just try and check what will come if you had both a laptop which was worth 12,000 and it depreciates every time, every year for like with 15%, what it is that you're going to get after 3 years. So calculate that and let us know on the chart so that we can be able to assist you. All right. Then we have nominal and effective interest rate. So here the nominal and effective interest rate, they come in a formula. So if you have seen it in most of the textbook, this is not how the formula is represented, but that is simply because they are just looking at them in a different scale. So you see it as 1 plus an interest of effective, right, equals 1 plus I divided by M and then to the exponent M, like that. But that is the same, because what happened there for us to end up there is just to take the 1 from our left, and if we move it to the right, we're just going to subtract that 1 both sides. So that's why we ended up with the 1 in this format, right? So you can be able to calculate that as well, and you can be able to find your effective rate as 12.68%. So let's try that. If I'm looking for let's do this one for visuality. If I'm looking for I effective, that will be equals to 1 plus my I is given to be 12, but remember the 12 had a percent, so it's 12%, which you can actually say percent or divide by 100, and then you can multiply that by 12 because it is compounded monthly and we have 12 months in a year, and then we're going to put the 12 there as well. Then you can take all this, if you multiply it together, and then if you work it out together and multiply by 100, you should be able to get 12.68%, just like that. So it does just show you that what will happen with the effective and the nominal interest in this case. All right. So since we have done the summary and you have seen what it is that you have to do, which formula to use when, and how you're going to use the formula, I will just give you a few minutes to settle down and just run to your laptop, internet, or go to Maski. Our number phone is 072-091-0388, and ask Maski to give you the question paper of 2018, right? It should be able to do that. But if you can't, because this is grade 11, then you can be able to go to the DBA website and then you can be able to find this. Or just go Google 2018 Mathematics Paper 1 question paper and it will give you this question paper. Otherwise, we have the question with you here. We can actually just do it together. And I'm just going to see you after the break. Stay tuned. All right, we are back again. Let's see if we are able to respond to these questions as we have been asked. So this question is usually question number 7 plus minus 15 marks that you will get for this question, right, in each and every exams. So here they are saying to us always, my advice is underline, make sure that you highlight what you have so that what you don't have, it's automated that you need to look for. Right. So let's read and as we analyze. Calculate the effective interest rate, right? So that is one that we know. This helps us to identify the formulas that we want to use as well. That is the rate per annum if an investment earns interest rate at a rate of 11.5 per annum, right? So if they earn the interest of 11.5 per annum, but it's compounded monthly, there's only one formula for interest rate. So what you're going to do is just write your formula that you had. So it is I effective equals 1 plus I divide by M to the exponent M minus 1. That if I put the minus 1 on the other side, simply because I'm looking for the effective rate, right, or effective interest rate. So by doing that, you can just simply go substitute what you have and then you'll be able to get to the answer. So let's do together as we are checking how the marks is also done. So you can see that I have done my formula in another way where in their space, that is the third part of it. But you can see that by identifying the formula itself, you do have the mark. And also when you come from there and you are able then to substitute whatever that need to be substituted in the formula, you get another mark, right? So that is 1 plus our I was given as 11.5. So please don't rush, just write 11.5% or divide it by 100 so that you know that is what you have. Since it's compounded monthly, as the statement, so you're going to multiply that 100 by a 12 and then you're going to have 12 like we did with the previous question there, and then you subtract 1. If you do that, you would have also managed to respond to what they want in a nutshell. So look, they said we are looking for effective rate, which is per annum, and also have 11.5% per annum. So this is what we have, and it's compounded monthly, which is your 12 there. So immediately you have done it like that. Please do not do anything. You just use your calculator and then you get the answer as it is. Right away, you just put your bracket and then you put 1 plus, and usually I like use a fraction like that, then it's 11.5. If you don't have the calculator that show the fraction, use brackets to separate the fractions there. It will also help you. Then we say divide by 100, multiply by 12, all to the exponent of 12, and then we subtract 1, right? As I did that, I got my answer to be actually 0.1212 and so on. Please do not move or remove anything on your calculator. What you need to do then is to multiply that by 100 for you to get an interest rate. Remember, we are looking for an interest rate, so it has to have its percentage. So when you get that, you must then multiply it by 100 for you to get to where you want to go, which is 12.13%. That will be your interest rate, right? So that important thing there is that you must make sure that you write the formula, and then after the formula you show the substitution, which is this part, and then you will show your answer. Please just bear in mind that you can use the formula that is it is in most of our textbook, which says 1 plus interest effective equals 1 plus I divided by m to the exponent m. So you are allowed to start with that formula. Still, they'll give you marks for it. If you move and just write interest of effective as the subject of the formula straight away, they'll also give you the mark for that. All right. Okay, so let's check the second question. The second one, they said, Karabo bought a computer for... So this one has bought it. For the fact that they have bought before anything else, just remember, we just showed that if you buy an electronic today, what happens is the moment you move away with it, it's starting to lose value. So with or without them telling you which formula to use, you already should know what does that mean. So they bought the computer, which was 4,700 rand, and the value of the computer depreciate, which means it decreases or it loses value at a rate of 18% per annum, right? So you are told that this is depreciating, and you are told the value of P. You are also told the interest, right, which is the I, the interest rate. Using the reduced balance method, calculate the book value of the computer after 4 years. What does 4 years mean? The 4 years represent our N. So you will go into your thing and you'll be writing, okay, I have P, I have N, and I have I. Right? By saying that, you have already given yourself what you have and what you don't have, and how you're going to calculate it, right? So that is what they've given us here. So this one, you're going to use a formula, A equals P, and then you have 1 minus, because it is depreciating, and then you use I to the exponent n, because we are using the reducing balance method. We are not using the straight line method. So that is your starting point, how you're going to respond to the question. And then you go on, you substitute 4,700. That is what you had, right? Because you want to calculate the book value of the computer after it has been bought. So how much will it be after it's bought? Then you then simplify or substitute that, which here is going to be 18 divided by 100, as we said, to remove that 100. And this is for 4 years in total. So we're going to use that 4 years there, because it was compounded, but it is per annum. So that is how you do it. And you will see there as well that they have given the mark for the formula, and they have given the mark for substitution. And then right after that, you just make sure that you get your answer by using the calculator right away. So please don't rush it. You just take your calculator and ensure that what you are doing on the calculator is actually what is shown there. So it's 4,700 multiplied by 1 minus, and then I just put my button for a fraction, divide that by 100. Remember, you can say percent from your calculator if your calculator allows, but if not, this is how you're going to do it. And that gives us a total amount of 2,124.97. Right. So that is how you would have responded to this question, and that's how the answer will be. And this is also 3 marks, so the marks will have been given in this format. For as long as you did properly, you'll be able to find your decimal in the proper way as well. All right. Okay. So let's analyze the third one, which is the longest because it has two of the questions at once. So let's do it step by step. They said Namhla made an initial deposit. The moment I hear deposit, I'm thinking you are trying to save or you are trying to invest, one way or another. So initially when I hear that, I would know that this one should use something that has a plus on it. So you know we have a straight line, and which is a simple interest formula, and also a compound interest. So Namhla made an initial deposit of 20,000. In this case, I'm saying this is my P, because that is the money that has been deposited into an investment account. So that shows me that I've invested. That means I'm going to use a growth formula, not a decay formula, right? So that account paid interest at a rate of 7.2 per annum. But what is very important here is that it is compounded quarterly, right? So this is your key. For some reason, you need to highlight it and make sure that you understand. It is compounded quarterly, not monthly. So you need to remember that. So when it's compounded quarterly, you say, how many quarters do we have in a year? Right, what is a quarter to start with? So you always have said that, because now this become how you're going to determine your N value. So you need to use that idea to determine your N value for that quarterly. It's not an N value, it's to help you determine the N value, right? So after 2 years, which is supposed to be your N if it was not quarterly, but because there's quarterly, which is 4, and also there's 2 years, that is simplifying to say to you, for some reason, N might be 4 multiplied by 2. So I'm already putting it down because this is what and how you need to do it. Okay. Then they said that after 2 years, the interest rate changed to, so this interest rate changed to what? To 7.8% per annum, compounded monthly. So that is where you always remember that monthly. How many months do we have per year? 12, right? So 4 years, which we can just put a number for, so we can remember. 4 years after his initial deposit, Namhla withdrew 2,500 from his investment, right? So we're going to do that step by step, but let's see what the question wants. Calculate how much Namhla had in this investment account after 2 years, right? So the initial deposit was made. So after the initial deposit was made, we need to calculate how much they've invested. So this one is literally going to be in a better state for us to focus on. What we need to do is just to put the formula of, so that is 7.3.1. The formula A equals P1 plus I to the exponent N. So this is the formula that is a positive, and it shows the growth, but we just have to remember what is N, how is N impacted, and all that. Okay. So that is what it is that we have to have. So now if you look at this, you will see that the P, we said it is 20,000. So you're going to label that 20,000. And then what is going to happen to your interest? Your interest here is 7.2. But then you need to focus on the fact that it's compounded quarterly. That affects our I as well. So that means every time you have a difference in I, you always have to focus on that or filter it in. So I usually just say divide by 4 for me to understand what am I doing here. So let me use a different color for you to counterpass that in. So let's divide by 4 because we are compounding it in, right? So we have 7.2, which should divide by 100, but then it is also divided by a 4 to accommodate the quarterly. But we have 2 years as they've indicated here. So what we're going to do then is to go into, and then we say we have our 2 multiplied by 4. So what happened is whatever you do at the interest rate, it's actually the similar thing that you need to do at the number or the period, right? So your interest rate will be divided, but your period will be multiplied. And that is how you treat this question. So if you go and then you look into that, then you multiply it out properly, you'll be able to get to the answer. So let's see. If I have 20,000, multiply that right away, it will actually give me 23,068.12 or 12 cents. So that is how you're going to calculate this equation, and you'll be able to get to the answer. I hope this makes sense. Let's do a quick recap. Whenever you are writing this, remember that your formula in grade 11, it has marks. So you have to get your 1 mark. Please do not neglect your formula, because that's where the mark is. And also your substitution, as correct as it is, you're going to get your other mark, and then the 3rd mark then go to the answer. So these kind of questions are literally the questions that you just have to know the formula, what I have, and what I'm looking for. And then you get to the answer like that, and you get the full marks. That's how they are doing it. All right. Okay. So let's do this. The last one, they said, how much will the investment be worth, right? 7 years after the initial deposit was made. So we made a deposit, but what is going to happen to this investment after 7 years? So if you go back to the statement, you will see that you have been told that there's another interest that came after 2 years, right? So this interest will then work right after the 2 years. And you also told that there was withdrawal that happened sometimes during the 4 years of the investment. So that's how we're going to respond to the question. So with this one, you're also going to use 2 formulas. Why are we using 2 formulas for this one? To actually subtract the withdrawed amount. So that's why I said you need to counterpass the withdrawal. So let's use the method. We have A equals P 1 plus IN. Why? Because we are still dealing with investment, and we are no longer going to use the 20,000 just because the 20,000 has been used on between the first 2 years. Now we are going to use what we have after the first 2 years that had happened as our p-value. So the p-value have changed to 23,068.12. The p-value have changed to that. Also, what else is going to change? Our interest has changed according to the question. So the interest value is now not going to be 0.72 anymore. It's not going to be 7.2, it's 7.8. So we can use the 7.8, which will divide by 100, but then we multiply by 12. Where is the 12 coming from? The 12 is coming from the compounded monthly statement. Remember, we said that this is compounded monthly. Okay. Let's see. So it's compounded monthly statement, which we had here. So if you check, they did say that it's compounded monthly for the time that we have 7.8% per annum. It's compounded monthly. So when we deal with that 7.8, we must make sure that we counterpass the monthly compounding there. So that's why we are multiplying it by 12 instead of by 4, right? So if you check there, we are still talking about our 2 years, but then we are multiplying it by 12 because it's compounded monthly. And then after you get to this answer, then you're going to get the answer. So there's 2 ways to answer this question. Since it's 7 years, if I start with this 2, then I'm going to use this one and I do the other years, which is like 3, right? So you can do them step by step, or you can do it right away using the 5 years, right, all together. So let's do it this way. When you do that, you're going to get your answer to be 26,000, right? That you get 26,949.12. But then remember, by this time, this person after these 2 years have withdrawn 2,500. So namhla withdraw 2,500 there. So what we're going to do is we're going to subtract that 2,500 as it was withdrawn. And then that will then give us the answer to be 24,449 and 12. Right. So that is after 2 years. So if you follow the steps properly, this is what is happening. But then after 2 years, there was 3 more years that were remaining for us to reach the 7 years. Then we then calculate our remaining 3 years using A equals P, 1 plus I to the exponent n. Please make sure that you always write the formula down, because if you don't write the formula, you might make a mistake and nobody will be able to trace when and how did you make the mistake. So here when we go, so every time it's compounded monthly or it's a compound interest formula that we are using, the time you stop with your answer is what now become your P, right? So now our P is no longer going to be 20,000, neither it will be 23,068.12. It's now going to be 24,449 and 12 cents. So that is what happens with the compound interest. Now that is going to be our P, and then we substitute the value of I and also N. Just remember that here our N is 3, but because it's compounded monthly, we're going to multiply it by 12. So our I then stay as 7.8 divided by the 100, which counterparts the percent, and we multiply by 12, which counterparts the number of months, since we are compounding monthly. And then you have 3, which is representing years, multiply that by 12, representing the month. All right. Then if you multiply this properly, you should be able to find the total amount of 30,871 and 61 cents. So that is how you get to the solution. So you can do them step by step like this, or you can actually do it in one row. Just when you do it in one row, remember to actually counterpass the minus, right? So you always have to remember that you have to counterpass the minus. So here, when we mark this one, we're always going to mark the formula once, because we have now 2 formulas, right? So we can't mark all the time the same formula. So since we have given a mark for the formula here, so when we come here, we're not going to give the formula mark, because we have given already the same formula a mark in the previous one. So this one, we're going to give a substitution of a particular answer. So here, for example, we're going to give you a mark for you being able to identify the 7.8 and also being able to identify that your N is now 24, not 2. Right, so that's where the mark will go. As well as whenever you decide to subtract your 2,500, we'll give you the mark for that. And then when you come to the second part, where you have identified that your N is now going to be 3 times 12, which gives us 36. That is what we are giving the mark for. Then after that, we give the answer. So you'll see how skeptical they become. They don't give the same answer or the answer all the time or the same thing marks all the time. So you need to also be very, very careful when you're responding to these kind of questions, because as they go step by step, follow each other, that is how they mark. If you make a mistake, it is possible that you make a mistake going forward. But remember that you always have to just write the formula down, substitute, because they can mark you at some point towards the end of the year, continuous marking whenever you make that mistake. But if there's no formula, we want to know where to mark, right? That's a tip. So please bear that and make sure that you can understand. This is for you. I want you to go and look for the 2017 question paper, and then you do the similar thing that we have done. Practice these questions and make sure that you can come back to us, ask question in any platform that you are able to access, and make sure that you keep this math thing, right? All right, I was just about to run and say good night, but I couldn't do that because we have one warrior that need to know and understand something. So we had something here which I have given you guys as a task for you to check if we can do this application together. So the example, let's answer it before we run, right? You guys have a few minutes to spare with me. Okay, let's do it together. So example here, we're saying a laptop is worth 12,000 and then it depreciated at 15% per year on a reducing balance. Calculate the after 3 years what happened. Remember I said the reducing balance is the other formula that we have, which is this formula here. Let's write it quickly. So A equals P1 minus I to the exponent n. So what do we have? We do have our P as 12, we do have our I as 15%, and we do have our N as 3. So that's what we do. We come and then we substitute, right? So we're going to substitute 12,000, since we said it's P, 1 minus 15 divide by 100, or you can say 15%, depending on your calculator, and that will have the exponent of 3. And you just quickly do that on your calculator. I am very sure that our warrior have checked that and have managed to get the right answer as we go. So this is 15 divided by 100 to the exponent 3. Okay, Boitumelo, I got you, warrior. Let's go. So, Boitumelo, I hope you have found that is 7,369 and 50 cents. Please chat with us and let us know if that is what you have got. Boitumelo, I'm very proud of you that you managed to do that by yourself wherever you are. Please stay tuned and make sure that you keep on asking questions. So this is how you're going to respond to these questions. So if ever they say to you, use the reduced balance depreciation, just remember that you are using the compound interest that have a negative sign. But if they say for a straight line depreciation, just make sure that you use our straight line one, which is with a minus in between. All right. Any other question, you guys can just pop it on the chat, find us in any socials, and ask Muskie. He will be able to assist you and make sure that you get to the answer. Our next session will be actually on number pattern. For more information into this, you can just chat with us everywhere. But for Muskie, you can actually save the number 072 091 0388. Then just ask any question, mathematical or not. Muskie will be able to help you as your personal tutor. But we will stay here as well at Muskie Miller Learning and Muskie TV. Everybody around the world, we are here for you. So please stay tuned with Muskie TV, and we will keep on coming and assist as much as we can. See you next week. Bye.
And now we enter our next exciting chapter with the launch of Maskieverse, an inspiring trio of innovations, our AI-powered learning companion, captivating TV content, and a vibrant playground for interactive learning, and our own dedicated app, all coming together beautifully to deliver learning outcomes through technology.